Hello, today we're going to be solving for x. We're going to look into exponential equations, okay? So let's say we have 2 to the power x is equals to 2 to the power 2. So what's important is that the bases on the same, the bases on side of the equation must be the same. For example, this one, we have base 2, then we equate the exponent, okay? X is going to be equals to 2. Let's say we have 2 to the power x is equals to 32, okay? So we're saying that in order to solve, the bases must be the same. So we have 2 to the power x. The 32, we can change it as to 2 to the power 5, okay? So the bases are the same. X is going to be equal to 5. Once the bases are the same, we equate the exponents, okay? So let's look into another example. We have 2 to the power 2x minus 16 is equals to 0. So what you're going to do, we're going to take the 16 to the other side, okay? It becomes what? It becomes positive. So we can square the 2 to the power 4. Ne? 2 to the power 4 is the same as 2 to the power 16. Then we have the same basis. Ne? Then we're going to equate the exponent. 2x is equals to 4. Then let's solve for x. We divide both sides by 2. X is equals to 4 over 2, 2. Let's look into another example. So in this example, we have 3 to the power x is equals to 1. Okay, we have 3 to the power x, but this side we don't have 3, but we know that a to the power 0 is equals to 1, meaning that any number to the power 0 is equals to 1. Then we can change the 1 there to be 3 to the power 0 so that we can have the same base, and then we do what to the exponents? We equate them. X is equals to 0. Okay, let's proceed. Another example that we have is 3 to the power 3x is equals to 1 over 81. Okay, we have 3 to the power 3x. This side we need to have the same base as 3. Okay, so we're gonna start first by changing this to have a negative exponent, right? And then we know that 3 to the power 4 is equals to 81. So 3 to the power 4 is equals to 81. Then we have 3 to the power 3x is equals to 3 to the power 4 times minus 1 is just going to be minus 4. Then we're going to equate the exponent, the same base, then we equate the exponent. We have 3x is equals to minus 4. Then we solve for x, divide both sides by 3. This one cancels this one. X is equals to minus 4 over 3. Okay, so let's look into another example. Okay, we have 4 to the power x is equals to 16x minus 1. Okay, so we have base 4. How about we change the 16 to have to be 4 squared, so that we can have both side of the equation to have the same base. Okay, so the 2 is going to multiply the x and the minus 1. 4 to the power x is equals to 4 to the power 2x minus 2 times minus 1 is going to give us 2. Okay, the bases are the same on both sides. Then we equate the exponent. X is equals to 2x minus 2. Then let's take the 2x this side, okay, or let's take the minus 2 this side and check the x this side. The minus 2 this side becomes positive, and then we're left with 2x. The s goes that side, we have a negative x. Therefore, minus 2 minus s is going to give us x. X is going to be equals to 2. Let's look into another example. In this example, we have 3 to the power x times 9 to the power x minus 1 is equals to 81. Okay, So we have 3, okay? Let's change this one to be 3 to the power 2, this one 3 to the power 4. So we're going to have 3 to the power x times 3 to the power 2, x minus 1 is equals to 3 to the power 4, okay? 3 to the power x times 2 times x is going to give us 2x, 2 times minus 1 is going to give us minus 2, which is going to be 3, which is equals to 3 to the power 4, okay? Here we have the same base, then we can add the exponents. The same base, we have multiplication, the same base, multiplication in between, then we can add the exponent. X plus 2x minus 2 is equals to 3 to the power 4. Then we made the bases the same, then what can we do? We can equate the exponent. X plus 2x is going to give us what? It's going to give us 3x minus 2 is equals to 4, okay? Then we're going to take the 2 that side, changes the sign, okay? 4 plus 2, né? Which is going to give us 6. And then we divide both sides by 3 to solve for x. This one cancels this one. Then 6 divided by 3 is going to give us 2. Okay? There is here. Let's look into another example. So we have 3 times 5x plus 1 is equals to 15, okay? So what you're going to do in order to have the same base on both sides, the one that is carrying the x is this 5, this one allows us to divide, né? We can divide both sides by 3, 5 to the power x plus 1 is equals to 5. So now we have the same basis. We can equate the exponent. X plus 1 is equals to 1. And you take the one that side of the equation, 1 minus 1, which is going to be equal to 0.